Hi there. Welcome to another session on high-yield routines. This session will focus on the routine of number talks. My name is Janice Nowakowski, and I'm the district teacher consultant for mathematics and numeracy in the Richmond School District. As part of the district's strategic plan, we're thinking about what it means to be a numerate learner. And part of developing numeracy across students in kindergarten through grade 12 in our district is thinking about mathematical foundations. And one of those mathematical foundations is computational fluency. And that is the focus and the goal of doing number talks. So number talks are a short instructional routine in which students share their mental math strategies and their thinking either about a number-focused image or an expression to solve. And on the left, you see an example of what that might look like in a classroom with a whiteboard and the teacher recording the students' strategies. The students might be sitting at their tables or desks or sitting on the carpet so that they can turn and talk to each other and discuss their strategies. Number talks are 5 to 15 minutes. They may happen at the beginning of a math lesson or at other times of the day. The most critical instructional routine in terms of developing computational fluency and the need for them to be done all year long. Students need ongoing practice with their mental math strategies, as well as communicating their learning and their thinking about operations, addition, multiplication, subtraction, and division. The routine of number talks is focused on thinking, learning, and communication. And that computational fluency builds from a strong understanding of number and the relationships between numbers. The teacher acts as a facilitator and a recorder of the student's strategies and intentionally chooses number strings and sequences those questions that they ask to build students' understanding and that connection between numbers over time. The other focus is on students developing mathematical discourse, how to build on each other's ideas using mathematical language, and also to prove and justify their solutions and their strategies, which is really the work of mathematicians. Some basic materials that you need for number talks are a whiteboard, some whiteboard markers, and then magnets of some sort to help demonstrate strategies that students are explaining or to provide a visual scaffold to students. So these are 10-frame magnets here. Just the individual circular magnets can also be used for multiplication and division and thinking about arrays. You can also use a chart stand as well. And regular markers. Students don't record during a number talk. Again, it is a focus on their mental math strategies and their oral communication. But you could do similar to what is done during number talks, once or twice a month to have students record their different strategies to solve particular questions, because we do want students to be fluent with different strategies by the end of the school year. This is an example of a number talk in a grade 1 and 2 class, and I chose 8 plus 5 to start off with, and I originally had the 10 frame set up with the blue dots representing 8 and the green dots showing 5, but they've been moved around as students have shared their strategies. And again, you can see here that I'm recording the student strategies and I'm also naming them. I'm giving them some language to use. On the top right-hand corner, you can see 11, 12, 13, 14, 21. And after I put 8 plus 5 up on the board, that was all that was on the board to start off with, and the 10 frames. I said, just think in your head. And what do you think the answer is? Don't call out. We want to, respect everyone else's thinking. Think in your head. And when I count down from 3, 3, 2, 1, call out your answer or your solution. So I recorded down all the different numbers that I heard. And it's really important to create a culture in your class where children are going to be able to feel safe to call out whatever they're thinking is the solution. And then I said, okay, who would like to prove their solution and explain their strategy? And then as students share a strategy, I turn and say, does everyone agree? Does anyone disagree? And if everyone agrees and there's no dissent, I put a little check mark. So that's one proof. And once we have 3 proofs, we can feel pretty confident that the answer to 8 and 5 is 13. Now, when I first present 8 and 5, I'm having them think in their head, and I have them put up their thumb in front of them. And this is pretty standard across number talks when you read the different books about number talks. You don't want students raising their hand and shutting down the thinking of the students around them. So just give me a silent signal here, put a thumb up to let me know you have the answer, and I can scan the whole class that way. Once you have a strategy and you know you can explain it, then you can put up a second finger. And then your job is to keep thinking about another strategy and think about how you would explain that, and then put up a third finger and a fourth finger. And as the teacher, you can keep scanning to see, okay, who's got one strategy, but who's got three now? Okay, so I'm going to wait till everyone's at least got one strategy before I call on some students. At some point, I might have them turn and talk and share their strategies so that everyone gets a chance to orally rehearse and practice how to explain their strategies. Because I'm not going to select, many students. I'm going to ask them, who's got a strategy? And let's see, one student said, making a double, 5 and 5 and 10. They saw the fives across the top, and then I can see that it's 3 more. So that's 13. And then I'll say, so who has a different strategy? And that's part of the discourse and part of the listening. So if student says, oh, I did doubles too. I'm like, well, that's not what I asked. I said strategy. And then you make sure you get, several different strategies before you move on to the next question. And again, you're building the students' repertoire of the strategies that they're hearing and that maybe they will use themselves. So some other thoughts on number talks. Number talks are a very specific type of math talk. They have specific criteria. Again, they're research and evidence-based. It's a research and evidence-based practice created initially by Kathy Richardson and Ruth Parker in the early 1990s, both from Washington State, to really engage students in meaningful mathematical discourse and sense making. And it really does, again, focus on computation and thinking about numbers. So there's other sorts of talks about numbers, like number of the day or different ways to make 89, but those aren't number talks. Those are just a type of math talk or another type of instructional routine. In BC, we have a meta big idea for kindergarten through grade 9 around computational fluency. And again, that is really the focus of number talks. Development of computational fluency requires a strong sense of number. So the foundation for any work with operations is always really understanding numbers well and being able to be flexible and fluent with numbers. And that means being able to see them in lots of different ways and play with them in different ways and have different strategies to engage with numbers and their operations. You can see for grade 2, 4, and 6, those are the big ideas around computational fluency at those grade levels. In kindergarten, you're not adding, subtracting, multiplying, or dividing yet formally, but you are laying the foundation for all of those operations. So your number talks can focus on decomposing and composing, combining and separating, 1 more, 1 less, 2 more, 2 less. And you might use dot images like on the bottom right, 10 frames like in the middle, or Reckon Rex, which is a 5-based abacus that you can see on the top there. And you could hold those up, as a concrete material or as an image for students to talk about. And that's how we sort of start into number talks with our earliest learners. Here's an example in grade 1. Again, did 8 and 5, had a couple students share their strategies. And as they were sharing, I was writing down the names because that was new language for many of these students. So I'm like, one student said, oh, I just counted up the dots. I'm like, oh, so you counted all. That's an important strategy. And then another student said, well, I saw 8 blue dots and then I went 9, 10, 11, 12, 13. I'm like, oh, that's called, in math, we call that counting on. When you start with one number and then count on the rest of, the next number. And so naming that for the students as well helps develop their really specific math language that they can use when they're sharing their strategies. Here's an example of a sequence or a number string, it's often called. So in a grade 1-2 class, I'm going to start with an access point that is accessible for all students. And that might be, 8 and 7. That would be a grade 1 expectation. So 8 and 7, and then the next question would be 48 and 7. So building on that, and you want students to see that not as a separate question, but to see that 8 and 7 lives in that 48 and 7, and same with 48 and 37, building up towards that, and providing access points for different students and their experiences, but also different curriculum standards as well. So an example for that particular question, 48 and 37, you can see I still have the visual scaffold of the 10 frames at the bottom that supported the 8 and 7, which will help them with this question as well. And then you can see the strategies. They're not named here, but this one here, the main one and probably the most common one, is decomposing by place value. So 48 decomposes into 40 and 8, 37 decomposes into 30 and 7. I add the 10s, 40 and 30 to make 70. I add the 1s, 7 and 8 equals 15. And then I add 70 and 15 to make 85. And that's how fluent we want students to be able to get by the end, of their grade level experience and being able to explain their strategies. On the top left here, you can see the student said, well, I know 48 is close to 50 and I'm going to make it 50 because that makes it easier for me to work with. So I'm going to take a 2 from the 37. So decompose the 7 part into 5 and 2. So take that 2 and make it 50. So then I have 50 and 35, and I can do that in my head. I know that's 85. And then here, this student did, well, I'm going to start with 48 and count on or add on. And I used an open number line to represent what they were saying they were doing in their head. So they, let me go back to that. So on this particular picture here, it says I added the 7. So that was 55. Some students, again, might have added a 2 and then the 5. And then I did 10, 20, 30. And that's what got me to 85. Again, you can see another way a student did it here where they went to the 2 first and then added the 10s and then the 3 more. But the open number line is a great way to share those strategies as students are explaining what's happening mentally in their head, what they're visualizing. After you've been doing number talks, and again, it's important to do them frequently and every week over the year, there comes a point in the year where students will say, oh, can I just show you? Because they've seen you model, how to record the different strategies all year. They feel confident that they can record it in a way so that their classmates can understand. And they're verbally explaining as they're recording. And again, more examples of how to use that open number line to show these different strategies. And these are additions and subtraction strategies for grade 1 and 2 and 3, but we also use the same strategies with decimal numbers in grade 4, 5, 6, and 7, and with integers and with fractions. So the same strategies are used across the grades, just with different types of numbers. This is an example of a number talk I did in a grade 4 and 5 class just last week. And I wrote 8 times 24 on the board. And I did the 3, 2, 1, had them call out. And you can see the only answer I heard was 192. And then there were 3 proofs. So that's the 3 arrows beside that 192 over here. So one student suggested halving and doubling. So doing 4 times 48 made it easier for them to think about. Then they did it again, 2 times 96. They know 96 is 4 less than 100. So that was how they figured out that particular question. You can see how I've recorded as the student was explaining. Another student said, well, 8 times 24 is the same as, and they had learned about repeated addition, 24 and 24 and 24 and 24 and 24. And I said, oh my goodness, there's so many 24s. Is there another way we could record that? And another student jumped in, and this is where that mathematical discourse comes in. Well, you could do all, 8 20s and 8 4s and think about it that way. And so that's when I introduced brackets and how to write that. And then, multiplying those separate parts and then adding those together. And then another student summarized it. Well, it's just this. And again, it's decomposing one of the factors to make it easier to do or, more accessible in your head. And then in grade 4 and 5 and 6, we also work on the strategy of halving and doubling. And we saw that in the previous question, but we don't teach it specifically like as a trick, as a way to do it. We will have done some teaching around this and building the concept up before you start to see it come through in the number talk. So you're not asking for specific strategies. You're not saying, well, I want you to use halving and doubling to do this question. You're putting the question up and you're hoping that the students are looking at the question and those numbers and saying, what strategy would work with these particular numbers? Because that's where that sense making and that reasoning and that thinking comes in. But prior to number talk, around where you're wanting to sort of have them think about, that might be your goal, that you're hoping that they'll have and double, that they'll apply that strategy. You will have taught and practiced that many times. And here you can see a student, started with an array of 4 times 8, and then they halved it and doubled it. So now they have an array of 8 times 4. And again, in another class, it was a 5-6 class, we were playing with this. So 16 times 16 might seem like I can't do that in my head. But if we have and double, now that we understand that that keeps the product stable, if I halved and doubled 8 times 32, well, maybe I could do that in my head. Let's have and double it again. And we can actually have and double it all the way down to 1 and have our solution as one of our factors. So playing with that first and then seeing if they use that in a number talk is sort of the intent of thinking about strategies. So similarly, a question like that might be your question, 16 times 35. And if you've been practicing having and doubling, are students going to notice, oh, well, I can't have the 35. Well, you could, but then you're not dealing with whole numbers. But I could have the 16, and then so I could double the 35. And then I know 8 and 7 is 56 multiplied by 10, 560. So these are just some of the curriculum connections that happen during number talks. And again, one of the reasons why, instructional routines are so important in math. We nurture those curricular competencies with every instructional routine that we're doing, because it's focused on communication and concepts and using thinking and reasoning. And then, of course, the number concepts or operations that will be used will be dependent on the grade level that you're focusing on, starting with number concepts through 10, multiplication and division of numbers, decimal numbers, integers, fractions through to grade 8. And just an example of how, here's a lesson starting with a number talk. You saw that 8 plus 5 slide earlier. That was with a grade 1-2 class where they all shared individually. And then the next question I put up was 28 plus 5. And this is where I asked them to turn and talk and share their strategies with their math thinking partner. So they each had a chance to share a strategy. And then I collected those strategies and shared them on the board. And then after that, the number talk opening to the lesson, they had a chance to continue thinking about those strategies with different centers or stations or invitations with different materials. So just some examples. How does knowing about 5 and 10 help you add numbers with 10 frame dice? A math game that they could make up at their just right level. So choosing a dice that they think would work for them, and then building numbers, whether they're 1-digit, 2-digit, or 3-digit numbers, adding and subtracting, and then thinking about what strategies they're using. Different ways to make 10, again, with different materials and structures like the 10 frame to support their thinking about decomposing and composing numbers. And then how many different ways can you solve? So not just one way, again, really nurturing that flexibility and that fluency with thinking about numbers in different ways and providing some tools to support them. Here are some key number talk resources that might be in your professional library at your school. The two on the left, I recommend for grade 2 through grade 9 or 10. They really talk about the 4 operations, and those 4 operations with different types of numbers, like whole numbers, decimal numbers, fractions, integers, etc. And Ruth Parker, again, is one of the authors on those and was one of the original developers of number talks. In the middle, for those of you that are early years, Strong Start Kindergarten Grade 1 teachers are 2 books by Kathy Richardson, really focusing on visuals, so dot images, 10 frames, different arrangements of different numbers to help students see how different numbers are composed and decomposed. And then on the right, the 2 books by Sherry Parrish. The top one, kindergarten through grade 6 or 7, and then the second one, Number Talks, it specifically focuses on fractions, decimals, and percentages, is good for grades 4 to grade 9 or 10 in our BC curriculum. There's lots of strategies explained in those books, as well as those number strings and sequences, enough for you to use all year long. The first edition has a DVD with it, videos to watch, and the second editions have QR codes that you can just scan and watch videos of those number talks happening in classrooms. And then also, just so you know, on the portal, on the math site in the portal, in the documents section, there's several sets of mental math strategy posters, both in English and en français, also both for primary and for intermediate. And thank you to Carrie Bourne for developing and translating the French math strategy posters for our district. So those are, you can print them out and put them up in your class, or you could print them out smaller and have students glue them in their notebooks so that they can refer to them for different strategies. And those were developed with teachers and students here in the Richmond School District. So as we come to the end of this session, I'd like you to think about how you will use this high yield instructional routine with your students. And thank you for joining me today.